Hey guys, this is Mr. Grice for Algebra Unit 10.2 Review, Linear Regression. So, if you don't have one already, go ahead and take out a TI-84 plus Silver Edition, or if you've got another TI-83, that'll work as well. But we're going to go through and do problems 1 and 2 together. So, number 1 says the highest salaries in millions of dollars of professional baseball players are given in the table below. So the top talks about the years, and this is the years after 1990, and they're talking about salary in millions of dollars. So the first thing we have to do is use the graphing calculator to create a scatter plot of the data set above and describe the correlation and its strength. So I have to put in data. Before I start doing any of that, I'm going to pull up my linear regression notes. Hopefully you guys have this too. So the first thing we have to do is hit second, y equals, and then enter. So I want to make sure that everything is highlighted just the way it is. And then after that, I'm going to move on to putting in the information. So we hit stat and then enter. And there's already a bunch of data in there that's not what I want. At least I don't know if that's what I want. So I'm going to clear all of that. Okay, so now that everything's cleared, I'm just going to start typing in all of the information. So 1, 2, 3, 4, 5, 6, 7, and 10. Okay, and I'm going to do the same thing with the y. So it's 4.7, 5.3, 6.2, 8.5, 9.1. Oops. See, sometimes when you're doing these too fast, you can make mistakes, like I almost did right there. 11, 12.5, 13.3, and the last one is 15. So before I take a look at what this looks like, I'm going to go and set my window. Now, it so happens that I've already done this problem, so everything seems pretty good for me. The x max, the highest number we see is 10, so I went a little bit above that at 5. And then our y max, the biggest y value, if we go and look at this, so we said the biggest one here was 10, so I went a little bit above that. And our biggest y was 15. So like I said, I went a little above that, and that's where I get 20. So let's go ahead and take a look at the graph, and that's what we get. So what can you tell me about this correlation? I can go back if you want to. Is it positive or negative? Yeah, it's positive. And then what do you think? It's not perfect. It's not weak. I don't think it's moderate. I think this one is strong. So I would say that the correlation appears positive and strong. Okay, so the correlation appears positive and strong. Now, what does it mean in the context of this problem? Well, what time are we talking about? 1990. So since 1990, who are we talking about? Professional baseball players, guys. So the salary, and we're talking about the salary of professional baseball players. What happened to it? Did it get bigger? Did it get smaller? Yeah, it increased. Okay, so next part says to calculate the equation of the line of best fit and round to the nearest hundredth. So to do that, we go to stat. I'm going to slide over to calculate, and I'm going to go down to linear regression. And once we get there, all we want to do is hit enter. I know my screen looks a little bit different, but when you hit enter, this is what you get. And we're going to round this to the nearest hundredth, which means the second decimal. All right, so we get the equation y equals 1.15x plus 3.31. And that's our equation rounded. All right, and what we can do with that equation is we can come back to y equals and do 1.15x plus 3.31 and graph it, and that's our line of best fit. And now that you can see that, yes, for sure, this was a strong correlation. Okay? All right, so use the equation, estimate what the highest salary was in 2013. So we're trying to figure something out. Remember that X is our years and Y is our money. And we're trying to find what was the highest salary. That's what we're trying to find. So I know that they told us our X, so that's what we're going to plug into. But here's the key thing. In 2013, this is after 1990. So to know what number to plug in, I'm going to take 2013 and I'm going to subtract 1990. And we get the number 23. So we're going to plug in 23 to this equation. Okay, so here I am. I'm just doing it as a normal calculator right now. I'm plugging in 23 plus 3.31. And we get 29.76. So that's got to be nice. On average right now, professional baseball players are getting, yeah, $29.76 million. Okay. And that's my final answer, so I'm going to put a box around it. Now, the next one is saying use the equation from part B. During what year was the highest salary 20.56? So they didn't tell us the years, but they told us the money, okay? So the money, 20.56, and then we're just going to use the rest of the equation. 1.15x plus 3.31. Okay? And let's go through and solve it. We're going to subtract 3.31 to both sides. We get 17.25 equals 1.15x. And then to solve, we divide both sides by 1.15. And we get that x equals 15. So in the year 15, no, that's not the answer. Remember, that's 15 years after 1990. So we're going to take 1990, we're going to add 15 to that, and then you get your answer of the year 2005. Okay. So, next one. The table of values compares the number of rainy days in June to the monthly attendance at a Paradise Bay water park. Question A says use your graphing calculator, create a scatter plot of the data, and describe the correlation between the two variables. So go ahead and pause your video, and you guys are going to do this on your own. Okay? We're going to go to stats, and I'm going to clear all this stuff out. And then you guys go ahead and fill this out and take a look at your graph. Okay? Good luck. Okay, so I've plugged in all the data. I'm just going to go through and do my Y max and my X max. So looking over here, the highest X value that I have for the number of rainy days in June is 25. So once again, I want to go a little bit higher than that. So my X max, I'm going to go 25. Now, my Y max, let's take a look at the highest number for the Y. For number of people, the highest number I see is at 21,600. So I want to go higher than that. And I'm going to go a lot higher in this case, just so I can see all the information. So I'm going to go 22,000 on that. Okay. And let's take a look at our graph. There we go. Now, what's the general trend of this graph? You should be saying it's negative. Hopefully you're writing your sentence already. Okay. So for my sentence, I wrote that the correlation appears negative and strong. So next part, calculating the equation. We're going to go to stat, calc, line reg, calculate. There we go. And we're going to, once again, we're rounding this to the nearest hundredth, the second decimal. Okay. So you should have gotten for that y equals negative 827.11x plus 24,171.66. So describe the relationship between the number of rainy days and the monthly pool attendance. Once again, let's just look at our graph. What happens as the number of rainy days increase? So as we're moving farther to the right, if we get more rainy days, how many people are coming to the pool? Yeah, a lot less. Write that in a sentence. Pause it. So I wrote as the number of rainy days increase, the pool attendance decreases. Because that's what happens. No one wants to go to the pool when it rains. All right, using your equation, determine the monthly attendance if there were only 17 rainy days in June. So we're going to use that equation. Just remember that X equals the days and Y equals the people. So they're telling us the X. Y equals negative 827.11, and that's what we're plugging into, plus 24,171.66. Okay, and you're plugging in 17. What was your answer? Is that what you got? You know what? I know exactly what you got. You got this number, 10,100.79. But guess what? You can't have 0.79 of a person. Even if they're missing an arm or maybe an arm and a leg, that's still a whole person. A baby isn't 0.79 of someone, okay? So when you're talking about people, you have to round that up to a whole number. Okay, I'm going to write this right down. People equal whole number. All right. Using your equation from part B, predict how many rainy days there were in June if the monthly attendance was 14,246. Okay, so now they're telling us the Y. So just remember that X equals the days, Y equals the people. Okay, So we're going to set this up. They're telling us the number of people that attended, and we're going to set that equal to our equation. Okay, go ahead and pause the video and solve. Okay, and when you do this, you should be getting 12 days. Okay, and once again, we don't say that, oh, it only rained half the day. It still rained that day. Okay, so it's a whole number because it's still going to affect the attendance of the pool. Okay? Well, guys, this is Mr. Grice for Unit 10.2 review. If you have any questions, please come see Ms. Carranza or myself. Otherwise, this is Mr. Grice signing off. Thanks for watching.